please make sure that you have Mathematica installed on your computer or that you have access to Mathematica on a campus computer. You can install Mathematica on your computer at no cost to you using the BYU Idaho license. The steps to do so are shown on the screen, and they're also available in the Technology Assignments folder on iLearn. Mathematica is much easier to use when you understand a little bit about the structure and organization of Mathematica. So this short tutorial is intended to give you some information about how Mathematica works. When you open Mathematica for the first time, you should see the Welcome to Wolfram Mathematica screen. If you click on the New Document button, which is shown here, it will open for you a Mathematica file, which looks something like this. Files in Mathematica are called notebooks, and this here is a blank Mathematica notebook. The Mathematica program has two distinct parts, the Mathematica front end and the Mathematica kernel. What you see here is the Mathematica front end. The Mathematica kernel is a program that runs within your computer that you don't see. When we want to execute a command using Mathematica, we type the command into the front end. We then hold down Shift and push Enter. This sends the command to the Mathematica kernel, and it's in the kernel where all the computation occurs. The kernel receives your command and returns an answer, and the answer is printed in the front end. You can see here on the screen that this says input 1 and output 1. So we sent in the command 2 plus 2, and the kernel sent out the answer of 4. In order to organize information in the Mathematica front end, the Mathematica program uses something they call a cell. There are several different types of cells. For example, here on the screen we see an input cell and an output cell. This is an input cell, and this right here is called the cell bracket. Notice that if we click on that, it highlights it, and that's highlighting the input cell where we computed 2 plus 2. And this is the output cell where we got the answer of 4. And this cell bracket groups those two cells together to indicate to us that they are connected to each other. There are several different types of cells available in the Mathematica program. You can find the types of cells by going to Format, Style, and this shows us a list of cells along with keyboard shortcuts to get those types of cells. We can see that the first type is a title cell. If we click on that, we'll see that it gives us a place where we can type a title. There is also a section cell. Notice that when we do this, the title cell has a cell bracket that encompasses everything following the title. Also with the section, everything within a section will be within the same section bracket. So if I were to come here and do more computations, we would see that our input cells and output cells are grouped together with a cell bracket, but these two groupings of input and output cells are grouped within a section, which are grouped within the title. If I were to create another section cell and create mathematical content within that section cell, we would see that the input and output cells are grouped together within the section, but this section is separated using cell brackets from section number 1. If you double click on the cell section bracket, it closes those sections and makes it so that your work is organized and you can open and just look at the parts of it that you want to see one at a time. When we want to type content into Mathematica, some content is easy to type, like 2 plus 9. Those are characters that are easy to type. But other content is difficult to enter using the mathematical symbols. So Mathematica use what they call palettes to help us enter mathematical symbols. If you go to Palettes and go to the Basic Math Assistant, it brings up a list of different commands that you can use within Mathematica. For example, if I wanted to take the square root of 16, you can see here there's a square root button. So if I click the square root button and then type a 16 and then hold down Shift and Enter, it'll tell me what the square root of 16 is. And there's a variety of commands here that we can use. You can see here we also find symbols such as pi and e and infinity. Each of these commands also has a keyboard shortcut. If you hover over the command in the palette, you can see that it tells you how to do the keyboard entry. Here we see the keyboard entry for the square root is Control 2. So if I hold down Control and hit 2, I get the square root button, the square root symbol, just like I would if I hit the button on the palette. Now that we know a little bit about how information is organized within Mathematica, let's take some time to learn the commands that help us graph functions within Mathematica. Visualizing graphs is one of the things Mathematica is most useful for in calculus. In order to talk about graphing in Mathematica, I've created a Mathematica notebook with a title, Graphing in Mathematica, and 3 section cells. Within each of these sections we will create an example of a graph using Mathematica. I encourage you to open Mathematica on your computer and follow along with these steps as we go through the tutorial. In order to create a graph, we need to enter the section cell. So here I'll go just beneath example number 1, and I'll move my cursor until it makes a horizontal cursor bar. And if I click there, we'll get what's called the cell insertion bar. That large horizontal line is a cell insertion bar, which means that we're ready now to enter a command. We're now ready to type our command to draw a graph. We're going to start by graphing y equals x squared, which we know should be a parabola. The command in Mathematica to draw a graph is plot with a capital P. It's important to recognize that Mathematica is case sensitive and you have to use a capital P at the beginning of your command. If you don't use a capital P, it won't work correctly. Notice that if I type PLO without the T, Mathematica doesn't know what that word means, so it shows the word in blue. However, as soon as I type a T, it shows that Mathematica does know the word plot and it changes the word to black. That's a great visual indication that you can use as you're creating commands in Mathematica. If you ever see a word that's in blue, Mathematica doesn't know that word, and you should think about whether you've misspelled it or forgotten to capitalize. Commands in Mathematica are always followed by a square bracket. So we'll type plot with a square bracket, and then we'll type in the function we want to graph. You don't need to type the y equals, so we just need to type the x squared. So to do that, I'll do x caret 2. After you type the function you want to graph, you type a comma. And then we need to tell Mathematica the domain of the function we'd like to graph. And we do domains using a curly bracket and telling it that we want to use values of x, comma, as x goes from -5, comma, to 5. Close the curly brackets. And that will then be the domain of the plot that we're going to create. And we're ready now to close the square bracket for the plot command. So a plot command always has the word plot with a capital P and then a square bracket. And then you have the function you're going to graph, followed by a comma, followed by the domain in curly brackets, and then we close the square bracket. If we hold down Shift and push Enter, we'll see that we got the graph of y equals x squared. After we create a graph in Mathematica, we'll see that below the graph we get some options that we can use to adjust the way the graph looks. For example, by clicking on Theme, you're given options where you can change the look of the graph. Under Labels, you can type in a plot label. You can label the axes, you can change the font, style, and size. So there's a lot of things that you can adjust about the graph using the commands below the graph. Let's look at another example of a graph. For example 2, we're going to create a plot. Again, we'll use the plot command with a capital P, followed by a square bracket. And now we need to type the name of the command, or the name of the function that we'd like to plot. So if we want to plot y equals the sine of x, we would do y equals, we don't have to type, so we need to type the sine of x. Now to type trig functions, they're commands, so they need to be capitalized. So we'll type capital S-I-N, followed by a square bracket, and then an x, and then we'll close the square bracket. So this is going to create the graph of y equals the sine of x. Then we do the comma. Now we tell it the domain as x goes from. At this point we need to put in -2 pi to +2 pi. So we've run into a place where we need to use some Greek letters. And there's several ways we can input Greek letters into Mathematica. We could simply type -2 with a capital Pi, so we can spell out a Greek letter, and it knows that that is the number 3.14, or pi. We could also do 2 times pi by finding pi in the palette, which makes it look like a pi. Or we could use the keyboard shortcut that the palette tells us about. If we hover over pi here, we see that the keyboard entry is escape p escape. So if we hit the escape button and then the p and then hit escape, it will make a pi. We then close the curly brackets to close the domain, close the square bracket to close the plot command, and then we can push Shift Enter and see the graph of y equals the sine of x. Besides the options for changing the look of a graph that show up below the graph, we can also insert options into our plot command. So the plot command is always y equals the function, so we type the plot and then the function and then comma, then the domain. If we do another comma before we close the square bracket for the plot command, we can do things such as plot style red. To get the arrow, we do minus sign greater than. If we do that, it'll change our plot to be red. Mathematica knows a lot of different colors, so you can do it in various colors. You can also change other things about the style of the plot. If you want to change more than one thing about the style, you put the things you're changing in curly brackets. So this says the plot style is going to be purple and dashed, so you get a dashed purple line as your graph. There really are a lot of options available to customize your graphs, and if you ever want to play around with what those are, Mathematica has a very good help menu. If you go to Help and go to Find Selected Function and type in that you want to look at plot, it will bring up examples, and in these examples you can look at different options. For example, here's an option where it shades what's beneath the graph. So there are a lot of different options that you can find using the help features of Mathematica. For our last example of graphing in Mathematica, we'll create a graph that shows 2 graphs on the same screen. So we'll use the plot command and then a square bracket. Now because we're going to graph 2 functions, we're going to use curly brackets to group those 2 functions together. So if I want to graph both y equals x squared and y equals the sine of x, I'll start by typing x squared, comma, then I'll type the sine of x. Again, it has to be a capital S, and you have to have square brackets around the x. And then you type a curly bracket. So that is saying we're going to plot both of these functions that are grouped together with curly brackets. Then we do a comma. Now we do our domain. We'll do it from -2 pi to 2 pi. And then we close the square bracket and hit Shift Enter. We can see here the graph of both of these functions. Now when I see this, it seems a little squished to me. I'd like to look at less of the y-axis. I don't want the y-axis to go clear up to 40. So that's another option that we can change. So I'll go back to the place in the command here between the end of the curly bracket and the square bracket where I can type in an option. And the option I want is to do the plot range, which are the y values, the range or the y values of the graph. And I want the plot range to go from -5 to 10. And when I do that, I see the sine curve a little bit better, maybe more like what I'd like to see for this graph. The third topic in technology assignment number 1 will be computing limits in Mathematica. In order to compute limits, we use the limit command, which is spelled with a capital L. After we type limit, we'll use a square bracket. You should be seeing a pattern in Mathematica. All Mathematica commands start with a capital letter and are followed by a square bracket. So we'll take the limit of, and now we need to type in our function. So we're just going to do the limit of x squared as x approaches. Now to do the approaches you do an arrow, so you do minus sign greater than, and then we're going to do as x approaches 3. So we know already that this answer should be 9, but if we close the square bracket and hold down Shift and push Enter, we'll see that we do get the output of 9, and Mathematica has correctly computed this limit for us. A lot of times, one of the hardest parts of computing a limit in Mathematica is figuring out how to correctly enter the function. Our next example is going to be to find the limit as x approaches 0 of the sine of x over x. So we'll type limit with a capital L, then we'll do a square bracket. Now we need to type sine of x divided by x, so we need to do a fraction. In order to do a fraction, we can use the palette and find the fraction button. If we hover over that button, we also see the keyboard entry. The shortcut for this would be to Control / so we could do that instead of using the palette. But now we'll type the sine of x, and again, because sine is a Mathematica command, we use a capital S and we put square brackets around the x. We then hit tab to take us to the other box that needs to be filled in, which is an x, and the right arrow will take us out of the fraction. So we can now type in that x is going to approach 0, close the square bracket, and push Shift Enter, and we get the answer of 1. For our third example, we're going to look at the limit of 1 over x as x approaches 0. When we do that, we get an answer of infinity. However, that should concern us a little bit, because if we look at the graph of 1 over x, it reminds us that as we approach 0 from the left, we get negative infinity, but as we approach 0 from the right, we get positive infinity. So as x approaches 0, the limit actually doesn't exist. But it turns out that Mathematica is computing one-sided limits, and it actually always by default will compute the limit from the right, which makes sense in this case. The limit from the right will be infinity. Now you can specify which direction you want the limit to be in. So if we say we want the limit of 1 over x as x approaches 0 with a direction of 1, we get negative infinity. If we specify the direction of 1, that means we're approaching from the left. However, if we copy that command and do the same thing with the direction of negative 1, we get positive infinity. So if we specify direction to be 1, that's approaching from the left. A direction of negative 1 is approaching from the right, which does seem a little bit backwards, so you have to be careful that you understand the appropriate direction.